Good morning, dear students. Until you learned about prepositions. A preposition is a declarative sentence that is either true or false, but not both. Now we are going to focus on predicates. Predicates are the statements involving variables which are neither true nor false until or unless the value of the variables are specified. So once observe, predicates are also statements involving variables. In prepositions, we don't have any variables. Here, predicates are neither true nor false until or unless the value of the variables are specified. For example, X is an animal. This is a predicate. Here the variable is x. X is greater than 3. Here also the variable is x. This x is greater than 3. X is an animal. So we can't say x is, the statement is either true or false until we give x equal to cat or elephant, giraffe, like that. The third example is x plus y equal to 7. All the above statements are neither true nor false, so they are not prepositions. After seeing this x is animal, we can't say this statement is true or false. That's why these statements are examples for predicates, not prepositions. In a predicate logic, the statement is divided into two parts. They are, first one is subject, second one is predicate. Consider the predicate X is an animal. In this statement, X is subject and is animal is predicate. In the above statement can be represented as P of X, and also you observe that only one variable X is present. That's why this P of X is called unary predicate, where P of denotes the predicate. That predicate is an animal. X denotes subject or variable. After assigning the value of a variable x, the statement P of x becomes a preposition. That means we can convert predicates into prepositions by assigning the value of variable x. After it converts into preposition, we can say whether the preposition is true or false. Here, P of, here you can observe P of that something. I am going to fill this something by car. So, the statement becomes the statement, the predicate, X is an animal becomes car is an animal. Now, this P of car becomes preposition. We all know car is an animal is false. That's why the truth value for this preposition is false. If I assign x as cat, then P of something becomes P of cat. So x is an animal becomes cat is an animal. So cat is an animal. It is true only. That's why truth value of this preposition is true only. A predicate can also be defined over more than one variable, and it is called binary predicate. For example, P of x comma y, x is greater than y. Listen, x is greater than 1. If we replace x by 6 and y by 3, then it becomes 6 is greater than 3. 6 is always greater than 3. That's why the truth value is true. The predicates are always denoted by capital letters and the objects by the variables are denoted in small letters in brackets. Here you can observe P is capital letter and the variables x and y are small letters. These are written in brackets. Consider the statements Vishnu is good, Samir is good. Here, good is predicate while Vishnu and Samir are the objects. If we denote the predicate by F and the objects by X and Y, then the above statement can be written as f of x and f of y. Here, f of x means Vishnu is good, f of y means Samir is good. Consider the statements Vishnu is good and field is green. So, P of G is field is green. F of x already we have taken, that is Vishnu is good. Here in between Vishnu is good and field is green, we can observe and is there. The symbol for and is inverted V. That's why the statement Vishnu is good and field is green can be written in symbols f of x and p of g. Third one, let q of x comma y denotes the statement x equal to y plus 5. What are the truth values of the prepositions q of 1 comma 3 and q of 2 comma 0? How we get q of 1 comma 3 means by replacing x with 1, y with 3. Then we get the equation 1 equal to 3 plus 5. The value of RHS is 8. That means 1 equal to 8, which is false. That's why the preposition q of 1 comma 3 truth value is false. In the next one, we are substituting q of 2 comma, we need q of 2 comma 0. So observe here q of 2 comma 0. Here only 5 comma 0, not it is 2 comma 0. So q of 5 comma 0. So replace x with 5, y with 0. Then LHS becomes 5, RHS becomes 0 plus 5, that is again 5. Therefore, LHS equal to RHS. That's why the preposition value of q of 5 comma 0 is true. Next, this is about predicates. Next, we move on to quantifiers. Consider the following statements. First one, all differentiable functions are continuous functions. All squares are rectangles. The value of some determinants are not equal to 0. For every natural number x, x square is also a natural number. There exists a real number whose square is equal to itself. So observe all these sentences. In the first sentence, we have all. In the second sentence, all is there. In the third sentence, some determinants. In the fourth sentence, for every natural number. In the fifth sentence, there exists. So, all of you observe, I think so. In the above prepositions, the words all, some, Their exists are associated with the idea of quantity. Quantity. Such words are called quantifiers. There are two types of quantifiers, namely universal quantifiers. What is meant by universal quantifiers? Let us see. Whenever the phrases for all, for every, for each are used in the statements is called the universal quantifiers, and it is denoted by the symbol like this V, and put one line like this. Second one is essential quantifiers. Whenever the phrases for some, there exists, and for at least one are used in statements is called essential quantifiers. And it is denoted by the symbol inverted E. This is like this. Write down like this. This is called there exists. This symbol is called for all. This symbol is called there exists.